Hey guys, so I'm going to try and make this video pretty quick, but what that means is I'm going to talk fast and you're probably going to need to pause. So our warm-up is first. Please get out your warm-up 312, 313 on the back or wherever you have space. You're going to do 314, and then you're going to actually turn this into the sub. So here are your warm-up questions. Please hit pause and then finish them. When you're done, hit play again. All right, here are the answers. Again, hit pause. When you're done, hit play. And if you didn't already correct or turn in 3.12, here are the first set of answers. Again, pause, make corrections. And here's the backside. Pause, make corrections. And then if you chose to do 3.13, which was optional, then pause and make corrections. Please pause and make corrections. That's the backside. All right, now pause again. Please turn in your warm-up to the sub if you did not already turn in 3.12 homework and or the optional 3.13. Turn that in. Remember, all homework is due before the test, which is the 28th. So here's our calendar. Oh, that is not today. Let's do today. Hughes is out. There we go. 3.14 square root functions. It's also the last day for test 2. I think most of you guys have taken care of that or talked to me about it already. But remember, test 3 is going to be the 28th. So we still have 2 lessons and a review. Notes and models. So today we're going to recognize a parent graph of a square root function, transform that parent graph, translations, reflections, dilations, and describe transformations based on equations or graphs. If you haven't already gotten 3.14 notes packet from the sub, please pause and ask for it now. Hopefully they already passed it out. All right, here we go. A lot of the same information, so I'm not going to go through much of this. The parent function is the most basic function. This time we're doing a square root function, so please add that into your notes. If I go too fast, please hit pause. I would also suggest maybe a little sketch next to it. Remember that y and f of x are the same thing. We'll do a couple of f of x's here and there, but I don't ever want you to get confused about what f of x means. Transformations, so it works just the same as quadratics and absolute values. The translation will shift left and right. That's anything inside the grouping symbol. So inside the absolute values, inside the parentheses, or in this case, inside the square root. If you add on at the end, you're going to shift up and down. Reflections, flip it across an axis or a line. In this case, it's always going to flip it across the horizontal x-axis. And then dilation stretches and compresses horizontally or vertically. We've talked about the vertex form. This one changes that the grouping symbol, our first grouping symbol was absolute values. The second one was parentheses with the square. And the third one is now square roots. Square roots are also called radicals. Oh, I don't think I put that in there either. So I think you have to write the word radicals in. And then the index on square roots is not usually written. So that little 2 in the index position will often not be written. So you'll just see it as the square root of x. We don't write the little squared in the index part. Square roots, like parentheses and quadratics and absolute value bars, are grouping symbols. To be clear which values are under the root, make sure that the root extends all the way over those values, or better yet, use parentheses to be sure. I can only type the starting symbol, so I'll be using parentheses, like the square root of x minus 2 plus 4. That x minus 2 is under the parentheses. So if I were to continue it, or I'm sorry, under the square root. So if I were to continue it out, it would look like that. So that would be a shift to the right of 2 and up 4. That's how we look at what's inside the grouping symbols versus that moves left and right versus what's outside of the grouping symbols moves up and down. Again, if I'm going too fast, please hit pause and make sure you fill all those in. So let's do the parent function. So we want to pick things that are very easy. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Let's plot that out. So 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 2, and 9, 3. So we get a curve that looks like this. That means it starts at 0, 0. My domain is starting a hard start at 0 and it goes through infinity. My range is a hard start at 0 and goes up through infinity. The vertex is at 0, 0. That's the end point that will shift around depending on these values. So this one goes left and right, and this one goes up and down. There is no line of symmetry. There's no reflection point. There is not a bottom to this. So it's not like a turned sideways quadratic. It is just that part of the line. So it's, yeah, just that part of the line. Remember, the game controller may help you visualize if outside the function I have a positive, it moves up, and a negative, it moves down. Inside the grouping symbol, if it's positive, it moves left, and if it's negative, it moves right. Then we have the vertex form. It looks exactly the same, except that now we have this square root. Okay, remember I'm having to put them in parentheses because I can only type the starter, but that's what it would look like if I could do the whole thing. So reflection flips it over. So instead of going up and over, it's going to go down and over. Dilations get vertically stretched. That means they're pulled upwards and they get higher, or vertically compressed. That means they get pushed downwards and lower. Remember, it's a curve, so this is no longer slope of a line like it is an absolute value. Translations inside the grouping symbol moves it left if it's positive and right if it's negative. It moves it in the K outside the grouping symbol, moves it up if it's positive and down if it's negative. That's that game controller. Again, if this is not familiar to you, make sure that you review all three of these lessons so that you can quickly complete problems like this. This is just a little diagram I left in your notes. So take a look at this. This would be a vertical stretch when the A is greater than 1. This is going to be a vertical compression. Sorry, my handwriting isn't good on this. When A is, oh my gosh, A is less than 1. So when we have a fraction, it's going to push it down. The same thing happens in the negatives. The negatives, if it's a fraction, it'll push it up and it'll get shorter. And negative integers will make it wider and bigger. All right, it'll pull it down. It vertically stretches it. All right, remember, if in doubt, table it out. And now we want to pick numbers that make the work easy. So let's take a look at these. Remember, I'm going to erase them each time as we work through them. So I kind of grade in our parent function there so that we can do a comparison. So this is a positive, so it's going to go up like the parent function. It's a 1, so it's actually going to follow the parent function. But we do have some coordinate shift. So we are going to be going, oh, and I just realized I can't go -3. I'm not going to re-record this, though. So you're just going to move this with me and I'll fix it in your notes. 1, 2, 3. So this -3 is going to be there and a +1. That is my new endpoint. So this was -3, okay, along that line. And I still am going to go up 1, right 1. That's going to be there. So remember, if I go 0, 0, 1 would be the square root of 1, 4 would be the square root of 4 would be 2. So this is the square root of x and x. So 1, 2, 3, 4, and up 2. Oh, sorry, from the dot up 2. There we go. So I'm going over 4 and up 2. Then I'm going to go 9 and up 3. So that's 4, 5, 6, 7, 8, 9, and up 1, 2, 3. There's my next one. I could actually go out to the next one after that, but it's going to follow. So if I were to drag this over, it should match my parent, and it does. But it's going to actually start in a different spot now. I'm shifting the parent version left 3 and up 1. All right, so let's try number 2. Again, if you missed that, hit rewind and pause. All right, this one is going to be flipped upside down because it's a negative x minus 3 minus 6. So this is going to follow the same line, only it's going to be negative, and we have a +3 minus 6 endpoint. So 1, 2, 3, 1, 2, 3, 4, 5, 6. There's my new endpoint. Okay, and then we're going to have there's no stretch or compression. So my x versus my square root of x is going to be 0, 0, which is my vertex, 1, 1, 4, 2, and 9, 3. So from this point, I go 1, 1. I'm going to go over 4, 1, 2, 3, 4, up 2. There's my next point. And then I'm going to go over 9. That's 5, 6, 7, 8, 9, up 1, 2, 3. And there's my curve. Now again, if I drag that curve up into the parent, it should be pretty close, okay? But I changed the vertex, so now it is going to sit there instead. Please pause and copy that. All right, number 3. Number 3 is a positive one again, but now we do have an a value. So it is going to change my x versus the square root of x by a little. So let's actually plug in some numbers and see what happens. So if I put in a 0 there, that would actually take the square root of -2. So my 0 doesn't actually work because what we know is that this is going to start at a 2, 0. So it's going to start right here. So I'm not going to have anything at 0, but let's do it at 2. 2 minus 2 is 0. 0, the square root of 0 is 0, times 2 is just 0. That makes sense. That's my vertex point. Let's pick numbers that make sense. So the next number I would want is a 4. So I need to put in a 6 because 6 minus 2 is 4. The square root of 4 is 2. 2 times 2 is 4. Okay, so let's look at where that is. So from the origin, my coordinate is 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So look at that. I'm actually vertically stretching it, right? It's a integer, so it's going to get pulled upwards. So let's pick another number that'll go in there. The next number that I'm going to want is 9. So what minus 2 is 9? That's going to be 11 minus 2 is 9. The square root of 9 is 3. 3 times 2 is 6. So 11 and 6. 1, 2, 3, 4, 5, 6. And actually, I can do the next one because I shifted this way over. And I'll fix that again in your notes so that that first one works. But if the next one I want is a 16, that's going to be 18, right? So 5, 10. Oh, wait. No. 4. So this was my 1. This was my 2. This was my 3. Oh yeah, I did that right. This is my 4. So I want a square root of 4 when I get done. So in order to get 16, I'm going to need, 18. I guess that was right. 18 minus 2 is 16. The square root of 16 is 4. 4 times 2 is 8. So over 18, so that's 5, 10, 15, 16, 17, 18, and up 8. So starting from that endpoint, it follows the same pattern, but because it's vertically stretched, it's going to be higher than the parent form. So make sure and pause and copy that down. Let's do one more. So here's my last one. This one is going to be a -1/2. So not only is it going to flip upside down, but it's going to get compressed. So let's pick some numbers that make sense again. So I don't have any shift here. So this is going to start at 0 and 3. So 1, 2, 3. So I don't have any left or right shift at all. So if I put a 0 in there, the square root of 0 is 0 times 1/2 is 0 plus 3 is 3. There's my vertex. Let's put a 1 in there. The square root of 1 is 1. -1/2 times 1 plus 3. So that would be a -1/2 plus 3, which is going to be a positive 2 and 1/2. So we'd go 2 and 1/2. So over 1, up 2.5. Remember, this is going to get squished, right? So let's get rid of that work. Oops. Okay, the next one. Let's go to 4. So the square root of 4 is 2. -1/2 times 2 plus 3. -1/2 of 2 is a -1 plus 3 is 2. So over 4, up 2. Oh, sorry. I made a little stray dot there. There you go. Okay. Let's do 9. So we have, get rid of this. The square root of 9 is 3. -1/2 times 3 plus 3. -1/2 of 3 is a -1 and 1/2 plus 3 would be +1.5. So at 9, we're going to be up 1.5. And we can actually do the next one too. 16, the square root of 16 is 4. Negative 1/2 times 4 plus 3. That would be a minus 2 plus 3, which would be a 1. At 16, I'm at 1. So this one curves down, but it is very flattened out. I kind of missed that one there, but you can make yours a little more accurate. So there are our 4. Please again pause and make sure that you have that information. This one, we're going to write, this is like y equals, this is like y equals, f of x is in blue and h of x is in red. So first thing that we notice is that these are both positive. Okay. Up 1 over 1, 1, 2, 3, 4, up 2. So this is a regular square root. It is not going to have, oh, here, I guess I could do this. It is not going to have an compression or stretch. Same here, we are 1, 1, 2, 3, 4, up 2. So this is also going to be a 1. Now we are square rooting, and we have our x. We got to figure out where it moved to. So the first one moved back 1, so plus 1. Then it didn't move up or down at all. We could put the 0 in there if we wanted. We could also simply say f of x equals the square root of x plus 1. Okay. H of x is this red one. It's going to have 2 shifts. It's going to have a horizontal shift. That is a negative 3, so positive 3 inside the grouping symbol. And it's down 4, minus 4. Again, you could shorten this up. H of x is going to be, let's see, the square root of x plus 3 minus 4. Remember that square root symbol needs to go over the entire thing, or you need to use parentheses to make that very clear. Again, pause if you didn't get that yet, and make sure that you're following along on how to make those happen. All right, describe the transformation. So first thing, this is actually going to be down because it's negative. The vertex is going to be at negative 5 and 0, right? So we're going to go left 5 because that's in the grouping symbol, and then not up or down at all because there's no value there, nothing. This is going to be vertically stretched, but we're going to be pulling it down. So I'm going to graph it like this. So we're going to pull that parent function down. So it's going to be vertical stretch. And so it's going to kind of go down. Sorry, my pen isn't all that great on this computer. So let's think about the domain and the range. So the domain is going to, we got to look at the vertex. So the furthest left it's going to go is a negative 5, but it's going to hard start at a negative 5, and then it's going to go through infinity. My range is how low will it go? Well, it's going to hard start, so solid dot at 0, and it's going to go up through infinity again. All right, give you a chance to try this one on your own. Please hit pause and give this one a shot in your notes. Don't hit play until you actually try this one. All right, there you go. This one's going up. It's a vertex of 0 and 2. It's going to be vertically compressed. So this one is going to go, so if that were the parent function, this one's going to get squished, right? Okay, so this would be the parent. Oh, can't really read that, but hopefully you're listening. The domain is going to start at 0 and go on through infinity, and it's going to start as low as a 2, right? We're starting up at a 2, and then it'll go up forever. Hopefully you got that one right. So today's objectives: recognize the parent, I didn't change this, parent graph of, I just didn't change this part, square roots, functions. Transform it by translations. Remember, left and right are inside either the absolute values or the grouping, or in this case, the root symbol. Ups and downs are the ones outside of the grouping symbol. Reflections, if you change the sign, it flips it over the x-axis, and dilations, stretch and compress. Just be able to describe transformations based on equations or graphs. Remember, homework 3.14 is due at the start of next class. We'll work the problems for which you have any questions. If you are a senior and you are buried by financial aid and applications this week, it is optional. You can do bits and pieces of it as you have time. And remember, 3.13 was also optional because that was the that short 40-minute day, and so I didn't give you the extra homework. If you give it a shot, if you try all of them, I'll give you an A+ for effort, and I'll just show you the corrections. So have a good one. I hope that today went awesome, and I will see you guys next week. Bye.